Hello out there, Dissector D with Science World Discovery here in Houston, Texas. So this past week, my middle school life science and my high school biology students got a chance to do the DNA extraction lab from strawberries. As I've posted it in various science teacher groups, I've had some people wonder and ask me, how do I do it? So I'm going to take the time to show you how to do it so that way you teachers can be prepared. So let's talk about the materials that we're going to need. You're going to need 50 milliliters of isopropyl alcohol. Usually they want the alcohol chilled, but room temperature works fine too. But if you're doing this for setup and things, you want to go ahead and get your alcohol and put it in the refrigerator and have it chilled ahead of time. You're going to need 50 milliliters of distilled water. Please use distilled water. Do not use water from the faucet. I mean, you can, but we want to be scientific about it. So most experiments require distilled water. You're going to need 20 grams of sodium chloride. Now, I'm doing this per setup. So if you're a science teacher and you've got 5 or 6 groups, each group needs their own setup for this. So 20 grams of sodium chloride and 25 milliliters of dish soap. You're going to need a Ziploc bag. You're going to need a funnel. You don't need the fancy setup like I do, but I have it for a reason to show you. And you're going to need some filtering paper. These are like Clorox wipes. I just washed them really, really good and got the Clorox off of them, because if traditionally you would use the coffee filter papers and they rupture a lot of the time. So we want to make sure we don't have that happen. Okay, so now, and then you're going to need a beaker to collect your findings in, and we'll talk about that in just a minute. Like I said, a Ziploc bag, and of course the star of the whole experiment, strawberries. So in this setup, I'm using 1, 2, 3, 4, 5. I'm using 6 strawberries. So what we want to do is you want to get your Ziploc bag and open it up, and you're going to put in your strawberries. Put them in. Okay, so I've already started squishing the strawberries. Now, tell your students 2 things to making this squish strawberry puree more successful. One, what I do is I'll close the bag off, but I'll leave a little opening right here so that way all the air gets out. Do not, teachers, I know that some of y'all have groups of boys, they'll be wanting to pound away at it. They'll bust the bag. It doesn't make sense. All you have to do is just gentle squeezing. If someone at their lab station has long nails, as I look over at my assistant who has long nails, be cautious of that. But all you want to do is squish, and you want to make the strawberry puree. Why do we do this? This helps break loose all the cells, okay? This gets the cells nice and loose for the next steps. Okay, so now that we've got our nice strawberry puree here, this would be the step if we were making jam or strawberry preserves. So now we're going to add in our water, our distilled water, and then we're going to I kind of like to just lightly slosh this around just to give it some area there. Now the next step is we're going to put in the dish soap. The dish soap, if you've told your students about this, the cell membrane is made up of fat, the phospholipid bilayer. So is the nuclear membrane. So the dish soap will help break open the membranes. So we add in our dish soap. The next part of this is kind of fun to do. I tell my students, do not bubble the solution. You want to make this not bubbly at all. So all you want to do is just give it very gentle squeezes, kind of rock it back and forth a little bit. Don't bubble it. Do not bubble the solution. So now that our dish soap is in here, by the way, people wonder what dish soap works best. The one that gets most of the grease out of the way, Dawn. Okay? Now we're going to add in our sodium chloride, our salt. So you want to go ahead, pour in your salt. The salt is going to bind the DNA, or start to bind the DNA to it. It's a positive negative charge between the salt and the sugar, the deoxyribose sugar. So we're going to slosh that around in there, and I'm going to come closer so you guys can see what's going on. So as you can see, the substance is moving around in there, and we're getting a good binding. We want to make sure that the salt is mixed in really well. We don't want that clumping of the sodium chloride. So we're going to keep going back and forth with that. And it's kind of fun. You know, you can talk to your kids about the DNA molecule and understanding the positive and the negative charge interaction between the sugar and the salt. And maybe even sing the DNA song, you know, we love DNA made of nucleotides, you know, that kind of stuff. Maybe even have a video showing that explains more about DNA as well. Now, once you have gotten to this stage, now comes the fun part of filtering this. So we got to filter this out, and that's going to take a minute or two, but I'm going to show you how we do it. Okay, so now that we've gotten our nice little sludge here made, we need to filter this out. What we need is the actual liquids of this content, of our concoction here. We need the liquid part, not the clumpy part, the liquidy part. So to help us with that, I have employed my lovely little filtering paper here. And we'll put that into the funnel, and then we will open up the end of the bag. And this is the fun part watching kids do. Teachers, if you do experiments with your kids, it's always a joy to watch them do things and watch their steps and procedures for doing it. So now we're going to go ahead and pour this in. And now you can see it is starting to drip. And as it's dripping out, this is the content that we actually want. You might have to sometimes facilitate it, meaning you might have to pick this up a little bit and squeeze the bag, which I'm going to do because you want a good amount of your filtrate to come out. So I'm going to pour in a little bit more, and I'll show you how to do that. So you'll just simply pick up your filter. Oh, look at that. Oh, wow. Lots of it's coming out. And then you'll just kind of give it some squeeze there real gently. And as you can see, we are collecting the our DNA solution here, but the DNA has not been shown yet. And sometimes it's going to bubble up. If it bubbles up like that, you want to bring it down closer because you don't want bubbles. Bubbles are not good. And then we'll continue to squeeze this out. So I'm just about done with getting my puree extract out of here. And I do have a little bit of bubbling in my beaker. And there is a way there is a kind of a trick that you can do to get that out. And I'll show you what the trick is. So I'm going to grab myself a paper towel here, wipe my hands down. And as a result of this, I have about 75 milliliters of puree extract. of this. So what I'll do to get the bubbles out is I'll take a paper towel, very gently just go and touch the surface of it just to pull the bubbles off. There we go. I'm going to set that aside. Okay, the grand finale. We get our alcohol, and you're going to get a stir rod. And this is a very thick stir rod. So what I tell students is you don't want to go ahead and start stirring right away. What you want to do is you want to pour in your alcohol and then just wait about 30 seconds or so. You will see a white gelatinous precipitate start to form. Remember, when two liquids come together and a solid begins to form out of it, that's what we call a precipitate. So we're going to go ahead and we're going to pour in the alcohol. And now the precipitate is starting to occur. And then we're just going to lightly stir that around. And I'm going to come closer so you guys can see this formation. Here it is. And then it's kind of slippery, but there goes the DNA, formed just like that. There's the DNA inside of the beaker. So very easy, very, very fun experiment. If you're doing this with 25 or 30 students or so, you can pretty much guarantee it's going to take about a whole lab period to do, which is about 45 to 50 minutes to do. Then some students are like, hey, can we look at this under the microscope? Give them that opportunity, but please be mindful that you're not going to see much because it's very fibrous. Just to keep in mind that this is a conglomerate of molecules, and remember that microscopes generally cannot see molecules. Students often think that once they do this, that they're going to end up seeing the double helix structure. No, they're not going to be able to unless your school has an electron microscope, and then you might get the Rosalinda Franklin 51 photo, but I doubt that's usually the case. But they will be able to pull out the DNA. All right. Thank you so very much for watching this video. I hope this video is very helpful and informative for you. Again, my name is Dissector D with Science World Discovery here in Houston. Just remember to keep doing science and Doctrina Scientia Cum Super Via, learning science with pride. Thank you.